Today we are working on section 1.3 in our textbook, 1.3, segments and their measures. Okay, we've talked about that lines you can't measure because a line is infinitely long. The answer is infinite miles or infinite inches long. Array you can't measure, but a line segment has two endpoints and therefore can be measured. So today we're going to talk about how we can do that. And as always, again, if you have your notes printed out, it's going to make your life a lot easier. If you don't, you're going to have to probably go back and get this presentation to fill in the notes because I'm not waiting for you guys if you have not yet printed out the notes. All right. So just to remind you, we did this last time as well, an axiom or a postulate is an accepted statement of fact. You don't have to prove them, they're just accepted. Okay, so now we're going to talk about our first statement of fact for segments, and that is the ruler postulate. The ruler postulate just says that the points on a line can be matched one-to-one with real numbers. Those are called the coordinates. Okay, if you think about it, it's called the ruler postulate. A ruler without any numbers on it wouldn't be very valuable. So you need numbers on them called coordinates so that you can make the postulate, so that you can actually determine measure. So that's the first part of the ruler postulate, that they can be matched one-on-one with coordinates. Okay. The second part is actually figuring out the distance. And the distance between points A and B, written as AB, is the absolute value of the difference between the coordinates A and B. Okay. The absolute value, so therefore it's positive, right? If you think about it, that makes sense that I am 12 feet away from Dwayne. Dwayne is 12 feet away from me. We wouldn't say that Dwayne is negative 12 feet away and I'm 12 feet away, or vice versa. We're both 12 feet away, so the absolute value always makes it positive. All right, so here we have for our notes, we're going to be using a number line a lot on this, so you have to know what a number line is. It looks like that. Okay. Again, the ruler postulate says that every point in a line can be paired with a real number. This real number corresponds to a point is called the coordinate of the point. And then finally, the distance. The ruler postulate allows you to measure the lengths of segments. And you do so by doing the absolute value of A minus B. So let's take a look at that one. I put an example. Imagine that point A there is at -1. And point B there is at 3. So I would just take -1 minus 3, do that out. That's the absolute value of -4. The absolute value of -4 is always positive, so it would be positive 4. Okay. And as I just said, like the distance between me and Dwayne is the same as the distance between Dwayne and me. They're the same distance. So if instead of doing AB, where I took A minus B, I could do the other way and say, what's the difference of AB or BA? It would be 3 minus -1, which is 3 plus 1, which is 4, absolute value 4. So whether I start at A and go to B, or whether I start at B and go to A, the distance is 4. And the way I can tell that is by taking the absolute value of the difference of the coordinates. Okay, I'll give you guys a minute or two to copy that down. All right, 20 more seconds. Five seconds, and again, if you don't finish it up, you can always go back and look at the presentation online to finish up your notes. If you have your notes printed out, it'll make your life a lot easier. All right, so let's look at an example problem. Okay. Looking at this example, can somebody tell me what is the value of st? How far is s away from t? Okay, I've heard some answers here. I've heard the right one yet, I don't think. 12, okay. So yeah, 12, how could you get 12? Okay, well, it's 12 because you could have simply counted, right? It goes 1, 2, 3, 4, 5, 6, but each of these is 2, so it's actually 2, 4, 6, 8, 10, 12. S to t is 12. Okay? Or you could look at from s to 0 is 4. Negative 4 to 0, that's 4. And from 0 to t, that would be 8. 4 plus 8 is 12. Or finally, you can use the formula that I just showed you. And that formula is, well, what's the value of s minus the value of t? Take the absolute value of that. So that'd be negative 4 minus 8, negative 12. The value is 12. Okay? So everybody try SV real fast. Everybody see what you can get for SV. Make sure you know how to do it. How far is it from point S to point V? All right. And Victoria, what do you think it is? 18 is the right answer. Right. How do I do that? Well, again, I could just count it. 2, 4, 6, 8, 10. Just count them up. Or I can use my formula that negative 4 minus 14 is going to be negative 18, the absolute value of which is positive 18. So we're 18 units away. All right, so in terms of the ruler postulate, does that make sense? Everybody know what we're doing here? Yes, to measure something? All right, great. So we're moving on to our next postulate. I'm sorry? All right, so we're moving on to our next postulate, which is the segment addition postulate. Okay. The segment addition postulate says if 3 points, A, B, and C, are collinear, that means, again, they're on the same line, and B is in the middle, or B is in between A and C, then AB, this piece right here, plus BC, this piece right here, equals the whole thing, AC. And again, if you look at it, of course it does. That's why it's a postulate. You can't prove it. You just know it is. That the sum of the parts, in this case A, B, and BC, equals the whole, in this case AC. So again, you want to have this in your notes. Give you a couple seconds to get this down. The postulate to segment addition postulate is, again, if 3 points A, B, and C, they have to be in a line or collinear, and B is in between, then the individual pieces add up to be the whole. In this case, AB plus BC equals AC. All right, I'm going to give you 15 more seconds to get this down, and then we're going to do a couple problems. All right, so let's do some problems here. So I'm going to do the first one, and I'm going to have you guys work on the second one to make sure you know what's going on. So EG, this entire line segment here, EG, is 59, and it's asking us how big are these individual pieces. Okay. Well, the first thing I would do is I'm going to use my segment addition postulate, which just tells me that the two pieces, in this case EF plus FG, put those together, and that equals EG the entire way. Okay, so now I just need to substitute in. I'm going to take my value of EF, in this case 8x minus 14, and put it where EF is. I'm going to take my value of FG, in this case 4x plus 1, and put it where FG is. I'm going to take my value of EG, which is 59, and put it where that is. So by substituting in, I do that. Now it's just a basic algebra equation, so I have to just combine my like terms, isolate x, and when I do, I get, in this case, x equals 6. Okay, but again, the problem isn't asking me how big x is. The problem is asking me how big are these two segments, EF and FG. So again, I need to substitute in. In this case, EF is 8x, 8 x's minus 14. So I'm going to substitute in 6 and say it's 8 sixes minus 14. Multiply that out, and I get that EF is 34. And then I do the exact same thing for FG. Instead of 4 x's plus 1, it's 4 sixes plus 1. Multiply it out, add them up, and I get FG equals 25. And then finally, as a check, I know that together, EG is supposed to be 59. So if I add up 34 and 25, indeed that is 59. So I know I got it correct. All right, so let me give you guys a couple minutes to try example number 3. It's very similar, just different numbers. So see if you can do example number 3, and we'll go over it in just a minute here. All right, guys, 30 more seconds, and we're going to keep moving here. 30 seconds to solve problem number 3, finding what JK and KL are. Okay, 15 seconds. All right, so Patricia, can you give me what is the first equation I'm going to use? Just the segment addition. Which segment plus which segment equals what segment?
4x plus 6.
Even before that, just give me just the letters. Even before that.
JK plus KL.
Equals?
JL.
Perfect. Okay, I hope everybody heard that. So that was JK plus KL equals JL. Okay. Does everybody see this? If you don't see this, now is the time to ask, because if you don't see this, you're going to be in big trouble for other stuff. I'm happy to make sure it makes sense. Okay, great. And then Patricia, you were doing the next step, so I'll just ask you. So then when you substitute in, what equation did you get?
4x plus 6 plus 7x plus 15 equals 120.
Perfect. So she just substituted in JK 4x plus 6, and for KL 7x plus 15, and for JL she substituted in 120. Perfect. So now we just have to combine our terms, isolate the x. In this case, x is going to be 9, and now I just have to substitute in. So 4 9s plus 6 is equal to 42. 7 9s plus 15 is equal to 78. And if I add up 42 and 78 as a final check, they equal 120, so I know I must have gotten the answer right. Okay. So people are talking questions? Just trying to figure out the algebra. Any questions? We're good? All right, so now is your time to ask questions. If any of these steps didn't make sense, have any questions, I'm happy to answer. All right, great. Okay, so I'm going to try an experiment here. We'll see if I can get it right. So Sydney, how old are you? 14. And Victoria, how old are you? Darn. Okay, so it didn't work. Jacob, how old are you? 16. 15. Okay, great. Okay. So Jacob is 15 and Victoria is 15. Okay? So it would be completely reasonable for me to say their ages are equal. Okay? However, I think we'd all agree that it would be ridiculous for me to say that Victoria equals Jacob. They're the same person. Of course they're not. They're different people, but they have some characteristic, in this case their age, which is equal. Okay? In geometry, that happens all the time. You're going to have segments that have the same length, but are not the same segment. Okay? So what we use in geometry to talk about that there's something is the same, is something called congruence. So first, let me show you the symbol. The symbol is an equal sign with a little wiggly thing over it. That's a symbol for congruence. And what congruence means is it just means numerical expressions with the same values or figures with the same measurements. So numerical expressions with the same values or figures with the same measurements, they're called congruent. Okay? Again, they're not equal, just like Victoria and Jacob are not equal. Their ages are equal. And if this were geometry class, therefore we could say that Jacob is congruent to Victoria because their measures are the same. But we don't really do that with people. We can do that with geometric figures. Okay, so congruence has numerical expressions with the same value and figures with the same measure. All right, and now let's talk specifically about congruent segments. Congruent segments are simply two or more segments that have the same length. And I drew an example down at the bottom. You can see that AB is 1 inch and CD is 1 inch. So we both know the measure of AB equals 1 inch, which equals the measure of CD, which is 1 inch. So the same measure means that they are congruent. I would write that AB is congruent to CD. So again, their measures are equal. The lines themselves are congruent. Okay, and the final thing I want to show you on here is notice these things called tick marks. Okay, they're going to notice these the little red lines there. They'll be flashing here so you can see them. Okay, those are flashing tick marks. Okay, what those tick marks mean is simply that if they're matching tick marks, it means that something is congruent. Okay, so sometimes the problem is going to have tick marks on it. So you're going to know that these things are congruent. And sometimes you're going to draw it on because there's going to be a diagram there and you're going to realize, oh look, this thing is congruent to this thing. I'm going to use a tick mark to make it easier for me to see that those things are congruent. So A, we guys know the symbol for congruence. We know what it means, having the same values, figures with the same measures, two or more segments with the same length, that's all congruent. And then one of the ways we can show congruence besides the symbol is with the use of these tick marks. If you have the same tick marks on the same things, then you know they are congruent. All right, so let's do a quick example. Are AC and BD congruent? So Alondra, how big is AC? Okay, great. How did you get it? You got 7. How'd you get that? You knew it was 1. Okay, so you counted. All right. So that's great. So she just counted to get 7. The other thing you could do again is you could always use our equation. In this case, a is -2, b is 5. Or sorry, c is 5. So -2 minus 5 is going to be -7. The absolute value of which is 7. All right. If we do the same thing for BD, B is at, looks like 3, and D is at 10. So 3 minus 10 is -7, the absolute value of which is 7. So are they congruent? The answer is yes. Therefore, they are congruent. So we would say that AC is congruent to BD because they have the same measure. Question? Yes, ma'am. That's an excellent yes. Okay, so that's a great question, Lana. So the answer is that the question is, do you need the line over it? Okay, so what that really means, so I'm already being lazy because it's such a pain it's already such a pain to have the lines over everything in PowerPoint. It's just very hard to do. So to answer your question, you would say that you can say that without the lines, AC equals BD, because without the line, that just is the measure of it. So technically you're right, these should have lines over them because they're congruent. The segment AC is congruent to BD. It should have the lines over it. I was just lazy because it's so hard to do. But that's an excellent point, Lana. You're right. So again, you can have two different things. You could say AC equals BD, or segment AC is congruent to segment BD. All right. So we've got one more thing to look on here. Okay. Usually in geometry is going to make you learn new words, and often they are ancient Greek words, hypotenuse, or we just learned axiom or postulate. Okay, but once in a while, geometry throws you a bone and gives you a word that's easy to remember. The midpoint is the point in the middle. Pretty easy. The midpoint is the point in the middle. So if a point is a midpoint, then it divides a segment into two congruent segments. If a point is a midpoint, then it divides a segment into two congruent segments. That's what a midpoint is. Okay. That's the point on the line where it's halfway in between, so that it divides into two equal segments. Okay. A segment bisector, sect just means to cut. Like you all are my 6th period section. I have geometry, and then we cut it into different groups, and those groups are called sections. Sect just means cut. Bi means two, like a bicycle has 2 wheels, or a bisexual is attracted to 2 different genders. So bisect just means cut into 2. So a point, line, ray, or segment that divides or bisects a segment into 2 congruent segments. And then I put a example on here for you. So you can see that line CD bisects AB. Therefore, M is the midpoint, and AM is congruent to MB. And you'll notice the use of the tick marks. The tick marks there show you that AM is congruent to MB because they have the tick marks there. Okay. So a midpoint is just if it divides a segment into 2 congruent segments, essentially it's in the middle, then that's the midpoint. And a point, line, ray, or segment that essentially goes through the midpoint, so it goes through M here, then it bisects it into 2 congruent segments. So really the only difference is a midpoint is a point and a bisector is a point, line, ray, or segment. Thirty more seconds. All right, so let's do a quick example of that. Example problem 5. If I know that Q is the midpoint of segment PR, then how do I find PQ, QR, and PR? All right, so what equation do I know is true? What's equal to what? Miles, can you tell me? If Q is the midpoint, then what is equal to what? What would I say? Or what is congruent to what? Is congruent to? Perfect. Hope you all heard that. PQ is congruent to QR. We can say the measure of PQ is equal to QR. And now we just substitute in. PQ is 6x minus 7, and QR is 5x plus 1. So I'm just going to put those values in. Now I can just solve for x, isolate x, and I get x equals 8. And then again, I just substitute in. So in this case, I have 6x's minus 7, so I'm going to call that 6/8 minus 7. Multiply that out, that's 41. Now if that's the midpoint, then QR better also be 41 if I got it right, so let's see if that's true. 5/8 plus 1 is 40 plus 1. Yup, that's also 41. So I know I must have done the math right because I got two equal segments. And then finally I have to find out, well, what's PR? PR is just from the addition postulate, the segment addition postulate. It just tells me that PQ plus QR equals PR. So that's 41 plus 41 equals PR. PR must be 82.